In this video, we're going to talk about for loops. For loops are a shorthand way to create a count-controlled loop, and a for loop really only makes sense in a count-controlled situation. If you're writing a event-controlled loop, then you do not want to use a for loop. A while loop would be much better in terms of functionality and clarity in your code. The syntax for a for loop looks like this. We have the reserved word for, and then a for loop is a shorthand way of creating a loop because it bundles together the initialization, the loop condition, and the update step all on a single line instead of having those dispersed throughout the loop itself. But the actual code that goes into the initialization, the loop condition, and the update step looks identical to how you would write it in a regular while loop. For loops are delimited by curly brackets, just like regular while loops, and the body of the loop goes between the curly brackets. Some students get confused about the for loop syntax and how it executes because it's written in that shorthand notation where you have the initialization, condition, and update step all on the same line. But just remember that the individual steps are carried out in the same order that they're carried out in a regular while loop. So we still do the initialization step just one time before the loop executes. Then the condition is executed at the beginning of each loop iteration. Anytime the loop condition's true, we're going to execute the loop body, and then following all the steps that are in the loop body, the update step will always happen. Then we'll go around and test the loop condition again. We'll continue to do that until our loop condition becomes false during one of our tests, at which time we'll continue on with the rest of the program. So let's look at a short example loop. This is a loop that raises a base to a particular power. So in other words, we're trying to figure out like what 2 to the exponent 3 is equal to. And this particular loop calculates the result. So you can see that we are going to ask for some user input. So I created a scanner and prompted for the input. Then I've read in both the base and exponent values from standard input. Those are both just integers. And then here's my loop. I'm going to calculate a total value, a product of all of the numbers. And so I created a variable called temp that just holds that product throughout the course of the algorithm. And then here's my for loop. It says start when j is equal to 0 and continue while j is less than the exponent's value, whatever the user entered as their exponent. And then here's my update step, plus plus j. One of the textbooks that I was using a few years ago used this plus plus syntax for increment updates. You can replace that with j plus plus. That's the syntax that our current textbook's using, and it's much more common. The body of the loop's right here. All we're going to do is this arithmetic expression that updates the value of temp, and we'll continue to repeat that as many times as we need to while j is less than the exponent. Let's type this into an example program, and then maybe we'll trace it with the debugger. Add it in my code here. And I need to import my scanner. Excellent. And that looks like my code's good so far. Let's build it to see if we have any syntax errors. So far it looks good. Since we're going to trace through things, I'm going to pause right here at the loop condition so that we can see how the value of the loop control variables is changing as the loop executes. All right, so I'm going to click the little debugger button so that we run it in the debugger. All right, so down here at the bottom, it turned me over to my console window because it's waiting for me to enter my user input. So it's prompting me to enter the base and the exponent. Let's do 2 raised to the 3rd power. So let's think about what the answer should be here before we run the program. If we raise 2 to the 3rd power, that means multiply 2 times 2 times 2. The answer should be 8. All right, so now we're executing through the program. You can see that Java's initialized my base and exponent values so that they are 2 and 3. It's also initialized the value of temp. That's the variable where I'm keeping track of the product as it's in progress. And so I've initialized that to 1. And now I've paused right here on the line with the loop control. This is before any of it executes, not even the initialization step it has executed yet. So I want to step into this function. I'm pressing the down arrow, and then you'll see that it has now initialized my variable j, so it's 0, and it also did the condition test to see whether 0 is less than the exponent. And of course it is. 0 is less than 3. And you can see that in IntelliJ, it listed all of the values over here to the side so that you can easily see the value of the exponent and the value of j. All right, so now I'm going to execute my line that updates the base. So just thinking through that, what that should look like, I have the current value of temp, that's 1, and I'm multiplying that by the base, which is 2. So 1 times 2, that's 2. And then I'm going to store that result back in my variable temp. So after this line executes, I expect to see temp take on the value 2 in my memory window down here. Sure enough, you see that temp is now updated and it's 2. So now I'm back up at the top, and the next thing that's going to happen is I'm going to do that update step because I just completed an iteration of the loop. And then after the update step, it will automatically test to see if that new value of j is less than the exponent. Let me press my down arrow again. And you can see that both those things happen. We updated the value of j, so it's 1 now, and we check to see is 1 less than 3, and of course it is, so we're executing the loop body again. Now we're going to do this arithmetic expression. We're going to multiply the current value of temp, that's 2, times the base, which is also 2. And 2 times 2 is 4. And then we're going to store that result back in temp. So when I press the down arrow, you'll see that the temp value gets updated. So it's 4. Now we're back up here in the loop test again. We're going to do the update step so that j increments and has a value of 2. And then we'll check to see if 2 is less than the exponent. It is. 2 is less than 3, so we should do the loop body again. And you can see that reflected right here. Now we're getting ready to do our body of our loop again. We're going to multiply temp, which is 4, times the base, which is 2. And that result's going to be 8. And then we'll store the result back in the temp variable as soon as I press the down arrow. And you can see that that temp value now has that value 8 associated with it down here. So now we're back up at the loop update step. So we're going to add 1 to j and then check to see is the updated value of j, which will be 3, is that less than the exponent value, which is 3. And so we're expecting that will be false. 3 is not less than 3. So let's see when I press my down arrow. Sure enough, we have completed the loop, and you can see now down here, the variable j is no longer on my screen. That's because of how I declared it here inside the loop control, kind of inside the for loop. When you do that, your variable j is only defined inside the scope of this particular loop. And so as soon as you finish the loop and cross over that final curly bracket, then your loop control variable j is no longer defined. So now we finished that, and we're going to print out our message to the user. As soon as I press the down arrow, it will print out the result equals, and then the current value of temp, which is 8. That's our expected output, which is good. And there it is. So that was an example of using a for loop to make a count controlled loop in Java.